Okay, let us see now the approach of finding work and power. So here we have work done by the variable force is obtained by either you get the force times the distance or the displacement, or work done is going to be equal to, we interpret from that time t1 up to t2 when work is being done. From when we start doing that work up to when we stop. Then we get the force times the velocity at which that body is moving. So now this is F times V. But when we just wanted to treat it like this, we get F times D. But if you want to treat it like this, because when we bring in time, that's when we'll be having power. So we get F dot V from T1 up to T2, where power is equal to FV. Let us see an example here. A particle of mass 4 kilograms, so we have a particle of mass, our mass is 4 kilograms. From rest at the point, so that's the point from rest. It moves with an acceleration, so our acceleration again is not there. Our acceleration as will be written as a column vector 4 to negative 3 meters per second square. When a force, a constant force F acts on it, find A, force F, B, velocity at any time t, then C, work done by the force F after 6 seconds. Okay, so we start by getting our force, part A. You know that always our force is equal to mass times the acceleration. So our force will be our mass, which is 4. Then the acceleration, which is 4 to negative 3. And from there, you can see that this one, our force there is going to be 16, 8, negative 12. And these are going to be newtons. As simple. So that's our force. Then part B, the one that's to get the velocity, you can give it in the vector form or you can leave it there. So the one that's to get the velocity, by that always our velocity is equal to the integral of the acceleration. Okay, so we have it there. So if we substitute our integral of the acceleration, which is 4 to negative 3, the what? The t. So when we integrate this, we shall get, when we integrate 4, we get 4t. When integrate 2, we get 2t. When integrate this, we get negative 3t. Now plus a constant of integration. Okay. Now, from rest, it means that now we need to get the value of this constant. When t is 0, it means that now this body, remember this body is from rest. It means that this velocity is going to be 0. So put in here, 0 will be equal to 4 into 0, 2 into 0, negative 3 into 0, then plus c, implying that our c is going to be 0. So writing our velocity back, now our v at any time is going to be equal to, this is going to be 4t, then 2t, then negative 3t. Meters per second. So that's what we have there. And then the next example, they are telling us that find work done by the force F after 6 seconds. So that our work done, part C, that's the velocity at any time. So our work done, we said it's going to be from T1 to T2 of force dot velocity, this is dot the t. So now, first of all, we need to get F dot V. So our F dot V is going to be our force, first of all, which is 16, 8, negative 12, dot V, which is 4t, 2t, then negative 3t. So it is going to give me this, get 64t, then plus this and this, you get 16t, then minus and minus, you get a positive. 12 times 3, that is 36t. And so the whole of this is going to be, this is going to be 116, because this is going to be 80 plus this 116t. So substituting it now there, then after we substitute it to that formula. So that is our FB. So now my work done is going to be from 0, because this body was from rest, our body was from rest. That's why my T1, I can do that from here, my T1 is 0, then my T2 is going to be 6. Why? Because this body was from rest. So after 6 seconds means that from rest we have 0 up to 6. So from 0 to 6, F11 6t dt. Integrate that, we shall get, this we shall get now, 116 is squared over 2 from 0 to 6. Okay. So from here, we put in the upper limit. So this will be 58 from 0, 58t squared. Sorry. This would be 58 t squared from 0 to 6. If you substitute, we have 58 into 6 squared minus 0 squared, which will give us 2088 joules work done. So that will be our answer. Alternatively, you can get work done using the idea of force. The idea of force times dot B. What does it mean? Order in the displacement. What does it mean? It means that now after getting this V, you go on to interpret it. Then you evaluate it at 6. Then after, you substitute into that. It's up to you. Anyway, that's it, members. I wish you well.